When you turn the key in your car, what's really happening under the hood? It is, and I'm not exaggerating here, a symphony of thousands of controlled, violent explosions every single minute. It's this constant, managed chaos, all just to get you where you're going.
So the big question is, right? How is it even possible that all that chaos feels like a smooth, quiet ride? I mean, it really feels like it should shake the entire car to pieces. Well, the answer to that is just a masterpiece of engineering.
The secret, it lies deep inside your engine, in this beautifully engineered part called the crankshaft. It looks complicated, but its whole job is to tame that chaos. The design is the key to turning raw, explosive power into smooth, controlled motion, and it does it all through this incredible art of balance.
Now, to really appreciate this amazing balancing act, we got to get the fundamentals down. So let's start with a little engine motion 101.
So what is a crankshaft anyway? Well, its job is to take that violent up and down shoving from the pistons, that's what engineers call reciprocating motion, and cleverly turn it into the smooth spinning force that actually turns your wheels. It really is the heart of the whole operation.
But, and this is a big but, those pistons aren't just gently gliding up and down. Nope, they are violently accelerating and then decelerating at incredible speeds, thousands of times a minute. And this generates these enormous forces that are constantly trying to just rip the engine apart from the inside.
And all of that brings us to the biggest challenge for any engine designer, the shaking problem. Let's dig into why an engine, if you just let it do its thing, would literally shake itself to bits. The best way to picture this is to think about a washing machine during the spin cycle. When all the wet clothes get stuck on one side, that violent thump, thump, thump that shakes the entire room. Yeah, that is exactly the kind of force we're talking about, only way more powerful and destructive inside an engine. And this imbalance, it's not just a little annoying shake. It is incredibly destructive. It causes these severe vibrations that just accelerate wear and tear, puts a ton of stress on critical engine parts like bearings, and creates all the noise and harshness that would make any car just awful to drive. So how in the world did engineers solve this incredibly violent problem? Well, this is where the hero of our story makes its entrance, the counterweight solution. You see these large lobe-shaped things built right into the crankshaft? Those are the counterweights. They are not just some extra metal. They are precisely engineered chunks of mass placed in the perfect spot to fight back against the powerful forces the pistons are creating. And here's how it works. It's actually a beautiful dance of physics. As the piston shoots up, creating this upward force, its matching counterweight is swinging down on the other side, creating an equal and opposite downward force. The two forces pretty much cancel each other out, neutralizing that vibration before it can even start to shake the engine. And the impact of this is just profound. By adding these counterweights, engineers fix all those problems we talked about. The vibrations are minimized, which means a smoother ride for you, the crazy stress on the engine's bearings is way down, and the whole engine is protected from the kind of structural fatigue that would otherwise destroy it. Now, to really appreciate the genius here, we need to go one level deeper. Because as it turns out, not all the moving weight inside an engine is the same. Not all mass is created equal. You've basically got two types of mass to deal with. First, there's rotating mass. These are the parts that just spin in circles, like the crankshaft itself. That's the easy stuff. You can balance that 100% with counterweights. But then you have reciprocating mass, the pistons, the rings, all the stuff shooting up and down. That can only be partially balanced, and that is where the real engineering magic has to happen. So, since a perfect 100% balance just isn't possible, engineers have developed even more advanced tricks in their quest for that perfectly smooth engine. Think of vibrations as having two different flavors. You've got the main vibration, the primary one. This happens once for every spin of the crankshaft. Our counterweights are awesome at fixing that. But there's a sneakier secondary vibration that actually happens twice per spin. It's caused by the weird angles of the connecting rods. Counterweights can't really touch this one, so some engines actually need completely separate balance shafts just to cancel it out. Engineers also have two main strategies they can use. A lot of high-performance engines use what's called an internal balance. This means everything is perfectly balanced right there on the crankshaft itself. But a ton of everyday cars use an external balance, where they add a little weight to other parts, like the flywheel. This makes the crankshaft lighter and cheaper to make. It's that classic trade-off between ultimate performance and cost. Okay, I know, that was a whole lot of engineering. But let's bring this all back to you. Why does any of this stuff actually matter when you're just driving to work?
Honestly, it's everything. A balanced engine is the difference between a car that feels smooth and refined and one that feels rough and cheap. It means you got a quieter ride, for sure, but more importantly, it means your engine is going to last longer. Less vibration means less wear and tear on bearings and all the other parts, which drastically cuts down the risk of a major breakdown. It's really the hidden science behind your car's reliability.
At the end of the day, counterweights aren't just some nice-to-have accessory. They are absolutely critical to the engine's design. They're the unsung heroes that are responsible for stability, for that smooth ride, and for the long-term health of your car.
So, next time you turn the key and you hear that smooth, steady hum, maybe you'll think about that incredible, high-speed dance happening just a few feet away from you. A perfect ballet of physics, all designed just to make your ride as smooth as possible.